Hello, everyone. I'm Padma Priya Mariappan.
I'm Laura Joel.
I'm Kader Suleiman.
I'm Mans Karim.
I'm Aaron Thompson.
I'm Datwan. And we are the Brain Hammers. Welcome to our data engineering project. Today, we will demonstrate our skills and understanding of Python, AWS, Terraform, and data engineering in general. Our aim is to create a data pipeline for managing sales and inventory data for a tote bag company. The objective is to develop an application to extract, transform, and load data from the company's operational database into a data lake and data warehouse hosted on AWS. The application will be reliable, secure, and deploy using code automation and infrastructure as code. Now let's get started.
The first stage is ingesting the data. We achieve this using an AWS Lambda function which connects to our operational database at 5-minute intervals to retrieve any new or updated data and stores the data in JSON Online format in our dedicated ingestion S3 bucket. The function uses the Systems Manager parameter store to store a timestamp of the last successful execution. This timestamp is used in querying the database on the subsequent run to ensure only new or updated data is ingested. The triggering of the ingestion lambda at frequent intervals ensures that our raw data is consistently updated and readily available for data processing.
The next stage involves the transformation of our ingested data into a format that conforms to the star schema in the warehouse. We complete this transformation using the processing lambda function. Our processing lambda function is triggered when new data is added to the ingestion bucket we showed in the previous section. When the processing lambda is triggered, it immediately and efficiently transforms the raw data stored in the ingestion bucket into the predefined schema, suitable for storage in our data warehouse. The processing lambda function transforms the data using the pandas library in Python. The data is then stored in Parquet format in a separate bucket for processed data.
The final stage is loading the transformed data into the warehouse. Our loading lambda function is triggered when new data is added to the process bucket. The lambda function then populates dimension and fact tables following the design of the star schema using SQL Alchemy. This ensures that our warehouse reflects the latest data updates and historical changes.
We have set up robust monitoring and alerting mechanisms using CloudWatch. Using the logging module in Python, in conjunction with AWS CloudWatch, we are logging informational messages displaying details of how each Lambda function is running. For example, whether or not data has been successfully added to the relevant S3 bucket. This ensures that any anomalies or issues with our Lambda functions are promptly detected and addressed. We receive real-time alerts via email, allowing us to maintain the health and performance of our data pipeline effectively.
We used Terraform to deploy our cloud framework following infrastructure as code principles and built a CI/CD pipeline to automate the deployment of our data application using GitHub Actions. This ensures consistent and reproducible deployments, reducing the risk of configuration errors and streamlining our development process. We have rigorously tested all aspects of our Python code, ensuring compliance with PEP 8 standards and exceeding 87% test coverage. Additionally, we have conducted thorough security assessment using tools like Safety and Bandit to mitigate potential vulnerabilities. We also used AWS Secrets Manager to safely store credentials for connecting to the Tote database and data warehouse.
Having loaded the data to our warehouse, we can utilize analytics and business intelligence tools such as Amazon QuickSight to generate insightful visualizations and reports. QuickSight enables us to create interactive dashboards that help in identifying new trends and patterns that serve the company's analytics needs. Here are a handful of QuickSight visualizations that we generated to provide valuable insight into the data in our data warehouse.
Thank you for watching.
Thank you for watching.
Today. Goodbye.
Bye.
Bye-bye.